Welcome to Night Chemistry, your midnight laboratory of calm. Tonight our lantern of curiosity glows for Rosalind Franklin, the incisive mind who coaxed hidden patterns from strands of DNA and forever changed the language of life. Feel the bustle of wartime London fade as blackout curtains settle, leaving a single study lamp where a teenager copies crystallography notes instead of counting bombing raids. Watch those pages turn into train tickets to Cambridge, where quiet courtyards cradle her first diffraction experiments, and on to Paris, where laughter and Fourier transforms spill from late-night cafés. Follow her back across the Channel to King's College, a Gothic labyrinth of stone corridors and humming generators. There, a fiber of sodium DNA trembles in a microdiffractometer, and a photograph numbered 51 sharpens beneath ruby-red safelight, an X-ray mandala so clear it rearranges the future. Yet acclaim drifts elsewhere, and she walks a separate path to Birkbeck College, charting the elegant symmetry of viruses while illness shadows her footsteps. Even so, every lattice she maps becomes a lighthouse for generations of genetic explorers. As the story unfolds, let intellect and injustice intertwine like the double helix itself, and allow the soft cadence of discovery to guide each breath. When the final candle gutters and the laboratory slips into starlight, may you rest knowing that brilliance, though sometimes unacknowledged, always leaves a trace upon the world. Blackout Lamp, London 1941. The night sky is starless, veiled by smoke and strict wartime blackout, yet an amber bulb still glows behind heavy curtains in a modest Notting Hill townhouse. Inside, 16-year-old Rosalind Franklin leans over a chipped wooden desk, her posture intent, shoulders squared as though refusing to bend under the distant thrum of anti-aircraft guns. She has pushed aside the evening newspaper, another column of bombsight statistics, to copy equations from a borrowed crystallography text into a leather-spined notebook already crowded with neat, decisive handwriting. The room is cramped but carefully ordered. A pocket watch given by her father rests open beside a stub of graphite. Its second hand sweeps on, measuring resolve rather than time. A kettle simmers on a paraffin stove, releasing a faint hiss that mingles with the muted heartbeat of the city under siege. Now and then sirens moan in the distance, their rising glissando suggesting danger and daybreak in the same breath. But Rosalind does not look up. She solves a Bragg angle, recalculates it, then underlines the result twice, as though scoring a private victory no enemy plane can erase. Across the hall her mother whispers a good night through the cracked door, reminding her to sleep while they still have electricity. Rosalind smiles but does not promise. Curiosity is louder than fatigue, louder even than fear, and tonight it is fixed on the riddles of atomic structure, the hidden architecture inside coal, inside proteins, inside every living cell. She sharpens her pencil, folds a fresh sheet of grid paper, and sketches concentric rings, imagining how invisible waves scatter when they strike an ordered lattice. Each graphite line feels like a lantern swung deeper into darkness, revealing more intricate corridors of matter. The blackout lamp cracks and gutters, dimming for a heartbeat. Reflexively she shields the page, as if to protect both her notes and the fragile safety of those beyond the window. When the filament steadies again, she exhales and traces a small diagram of a camera-like device she has never seen but already understands. An X-ray diffractometer. She labels the beam path, the rotating crystal, the photographic plate. Someday, she thinks, she will stand in a laboratory where glass capillaries hold molecules in taut, glistening threads, and she will coax patterns from them the way astronomers net constellations. Someday she will question why women's hands are considered unfit to tighten bolts or align optical sights. She will tighten them anyway. Another distant explosion trembles the pane. Dust drifts from the ceiling rose and settles on her half-finished calculation of interplanar spacing. Instead of brushing it away, she studies how the motes dance in the lamplight, mapping random paths that mimic Brownian motion she once read about in Einstein's papers. Even chaos, she suspects, obeys deeper symmetries waiting to be named. She stretches, rising to pin a new sheet over the mantel. Photographs of family, holiday beaches, and a pet terrier make room for a crude chart of wavelengths and diffraction angles. Along the margin she writes a motto in soft pencil: "Science and everyday life cannot and should not be separated." It is her quiet rebellion against nights like these, when the world seems determined to reduce life to survival alone. Midnight passes. The sirens fade to a low wind. From the street comes the distant clatter of bicycles as air raid wardens finish their patrols. Rosalind closes the textbook, but not her notebook. She rereads the day's entries, checking every fraction with a finger that smells faintly of graphite and ink. Satisfied, she folds the blotting sheet, slips it between pages, and finally allows her eyelids to drift half shut. Yet her mind keeps tracing lattices, stacking layers of atoms like bricks in an unseen cathedral. When she moves to extinguish the lamp, she pauses, struck by a sudden image. Not coal, not graphite, but something grander. An elegant spiral staircase made of paired rails, twirling forever upward inside the chamber of each cell. She cannot name it yet. Almost no one can. Still, the thought settles like seed crystal in supersaturated solution, invisible but destined to grow sharp edges. She lowers the switch, plunging the room into soft monochrome broken only by moonlight leaking through the curtains. For a moment she listens. No engines, no alarms, only the faint murmur of the city breathing after danger. Clutching her notebook, she slips beneath wool blankets laid out on a narrow iron bed. The mattress springs sigh, the pencil falls to the floor, and curiosity curls beside her like a vigilant cat, ready to leap awake at first light. In a few hours she will rise, board a crowded bus to school, and recite Latin verbs while mentally rearranging diffraction patterns. But for now, amid the hush of temporary peace, her calculations rest, glowing unseen on the edge of discovery. Intellectual sparks. Morning returns to the same townhouse on Pembridge Square, and overnight the acrid smell of smoke has thinned just enough for a pale wedge of sunlight to slip between the blackout curtains. It lands across a polished mahogany banister and spills down the staircase like a shy visitor, revealing framed photographs of family excursions to Dartmoor and the Lake District. In one picture, a much younger Rosalind, knees smudged with chalk dust, stands triumphant beside a rock face where she has outlined mineral veins with a piece of blue slate. The expression on her face, somewhere between wonder and mild impatience, tells you that she has already begun measuring the world against the precision of her own questions. Downstairs, the household stirs into ritual. Her mother, Muriel, moves quietly through the kitchen, arranging thick slices of bread beneath the circular grill of a brass toasting rack. The radio is tuned low to a BBC announcer who insists, with clipped resolve, that last night's barrage caused only minimal disruption. Between sentences, there is a telltale flutter in his voice, the trembling pause of someone who has learned to compress entire maps of devastation into courteous phrases. Muriel twists the dial until the signal fades to static. Silence, she believes, is kinder first thing in the morning. At the long oak table, Rosalind's father, Ellis, is already seated, poring over a ledger from his bank. Lean hands cradle a fountain pen, its nib poised above columns of wartime loans and reconstruction notes. Though the numbers are urgent, his thoughts drift toward his eldest daughter, who has not yet descended the stairs. He is proud, prouder perhaps than a conventional parent of 1941 Britain is supposed to be, of her fierce pursuit of science, of her refusal to play merely the hostess at dinner parties. He checks his pocket watch and allows himself exactly 5 seconds of worry before closing the ledger with a soft thump. Worry is a habit he tries to keep as precise as interest rates. Upstairs, Rosalind stands before a small mirror, fastening the clasp of a sensible grey cardigan over a collared blouse. The smudges of fatigue beneath her eyes are easily disguised by youthful resolve. The slight swelling at one knuckle, a graphite bruise from last night's calculations, she massages absent-mindedly. She slips her notebook, now nearly half filled with Bragg equations, into a canvas satchel that also holds Latin translations and a dog-eared anthology of romantic poetry. The latter is a secret indulgence. She has discovered that reading Wordsworth's Wandering Clouds can refresh the mind as effectively as a brisk walk, and walks have become shorter since shrapnel littered the pavements. She descends the stairwell with measured haste, every step planned so the satchel does not slap against her hip and disrupt her train of thought. Halfway down, she pauses to adjust a framed charcoal sketch her younger brother drew, an imaginary skyline where factory chimneys are replaced by colossal test tubes. The picture is slightly askew, and the asymmetry bothers her enough that she nudges it straight. Already her mind is solving angles. "Good morning, my darling," Muriel greets, pressing a warm slice of toast into Rosalind's hand. Her palm lingers a fraction longer than necessary, conveying a silent contract of care. The mother's eyes flick to the satchel, heavy with more than textbooks. She wants to ask if Rosalind slept but senses the answer. Only as many hours as curiosity allowed. Instead, she brushes a stray strand of dark hair behind her daughter's ear. Small gestures must do the work of lullabies. Ellis folds his newspaper and gestures for Rosalind to sit. On the front page, headlines announce yet another factory blitz. Tucked beneath is a smaller column about a new radar installation on the Kent coast. Science, he notes, wins battles as often as it mends lives. He clears his throat. "I hear Professor Randall will be lecturing at St. Paul's School this Friday," he says, careful to keep his tone casual. "Might be worth attending if you can manage the allocation tickets." Rosalind's eyes brighten, though she pretends to consider. "I think I can manage," she replies, spreading marmalade with the efficiency of someone drawing a diffraction ring. She does not mention that she has already penned several questions for the professor, and rehearsed them in her mind between siren bursts. Curiosity, once kindled, arranges its own appointments. Breakfast concludes with a briefest grace note of normalcy. The clink of china, the faint rustle of newspaper folds. Then Ellis stands, retrieving a bowler hat from the sideboard. He rests a hand on Rosalind's shoulder. "Courage," he whispers, a single word they have traded back and forth since the first bombs fell. It is not the sentimental comfort of a lullaby. It is a ledger entry of resolve, to be balanced again by nightfall. Minutes later, Rosalind is on the pavement, gloved against the cold, her satchel hugging her side. Smoke still hangs above the rooftops, turning sunbeams into reluctant spears of ochre light. She steps deliberately around loose bricks and glistening shards of shattered shopfronts. Each fragment catches her attention. The sheen of broken glass reminds her of mica plates, their cleavage perfect along crystalline planes. Even destruction offers lessons in structure. At the bus stop, she meets her friend Ida, cheeks flushed beneath a knitted scarf. Ida is reading a pamphlet on women's auxiliary services and glances up with practiced cheer. They exchange updates. Ida's brother has shipped out to Alexandria. Rosalind's cousin has returned from Dunkirk with stories of phosphorescent waves blooming under propeller engines at night. Rosalind files that image. Molecules excited under pressure emitting light, as another phenomenon to research someday. Conversation drifts, as conversations often do now, between ordinary hopes and extraordinary threats, but always it loops back to exams, to scholarships, to a future they insist upon visualizing. The bus arrives with a pneumatic hiss. Inside, windows are painted half black at the top to prevent interior lighting from guiding enemy pilots. Passengers sit in a twilight of rationed daylight, faces ghosted by reflections. Rosalind stands near the rear, notebook open against the cold metal pole. She writes a new heading, Effect of Atomic Number on Scattering Intensity. The bus rattles over a pothole, blotting her ink, but she does not curse. Instead, she observes how the blot spreads, a viscous circle obeying surface tension laws. Real laboratories, she notes, are everywhere. They disembark near St. Paul's Girls' School, its grand facade now armored with sandbags. Inside, The assembly hall smells of chalk dust and damp coats hung to dry by radiators that barely function. Morning chapel has been replaced by air raid drill. Rows of students rehearse single-file evacuation to basement shelters. Rosalind finds the procedural monotony oddly calming. Timing the descent rate of each form, she calculates how quickly the entire body of pupils can reach safety. Precision, even in fear, is a kind of hymn. Latin class begins. Miss Probert dictates Virgil, but Rosalind's attention splits effortlessly. One part conjugates verbs. The other continues refining last night's brag reflections, testing her mental math against the numerical margins of the notebook. By now she can convert angstroms to nanometers without glancing at the conversion chart taped inside her desk lid. The dual concentration is smooth, like counterpoint in a Bach fugue. During the short break she retreats to the science wing, an annex with high windows that rattle in every distant explosion. In the chemistry store cupboard, dusty but silent, stands a small spectroscope, a relic reserved for post-war demonstrations. She peers through the eyepiece at a sodium flame left smoldering by a technician on tea break. The bright yellow doublet leaps to her retinas, pure and sharp as trumpet notes. She imagines a future classroom where children trace these spectral lines to the electron shells of quantum theory, and she makes a private vow to push that day closer. Lunch is taken in the underground gymnasium, repurposed as a canteen. The menu, powdered egg sandwiches, tea, and apple bruised but precious, disappears quickly. At a corner table, Ida confides that her mother worries about her pursuing mathematics instead of nursing. Rosalind responds not with platitudes but with a concise argument, that nations recover not only on healed bodies but on innovations born in resilient minds. Her voice is calm, the cadence of someone stating an axiom. The afternoon brings physics practical. 24 girls huddle around iron retort stands and delicate glass thermometers. Their assignment is to plot cooling curves of heated copper cylinders. To most, it is a necessary exercise. To Rosalind, it is a window into phase transitions, latent heat, and the curious way energy hides within structure. She volunteers to record readings at half-minute intervals. As minutes pass, the descending mercury becomes a choreographed waltz, each drop marking the silent glide from disorder to steadiness. She sketches the resulting curve in her notebook, annotating it with potential errors. Ambient draft, imperfect thermal contact, human reaction delay. She loves, above all, uncovering the fine print of precision. School ends under a slate-gray sky. The walk back to the bus stop skirts a bombed-out chapel whose stained glass fragments glitter among rubble like confetti from some mistimed celebration. Ida wonders aloud whether post-war Britain will still have Sunday services. Rosalind counters that sanctuaries can migrate. Perhaps the new temples will be laboratories, she says, half smiling. Ida laughs, but later she will repeat the phrase to her mother, who will ponder its sincerity. On the bus home, dusk gathers. Overhead, barrage balloons float like tethered moons, their cables humming against the wind. Rosalind flips to a fresh notebook page and begins summarizing the day. Latin imperfect tenses, sodium D-line wavelength, copper cooling constant. She concludes with a single enigmatic sentence. Order lies hidden within collision, a thought prompted by the random collisions of people, ideas, and bombs that seem to define her city. When the bus deposits her at Pembridge Square, the street lamps are already dimmed to pinpricks. She pauses at the corner, inhaling the scent of coal smoke and rain. Somewhere, a factory whistle sounds, echoing through the torn silhouette of rooftops. Despite the chill, she walks slowly, counting paces between lampposts and noting how each shadow overlaps like layers in a photographic emulsion. Her mind continuously photographs the world. Exposure, focus, develop. Inside the hallway she hangs her coat, exchanges brief updates with her mother, and climbs to her attic retreat. The blackout curtains are drawn anew, but she leaves a small gap so the moon can cast a slender bar across her desk. She sits, opens the crystallography text again, and resumes the conversation she left only hours earlier. Outside, the city braces for another night of sirens, but within these cramped walls, intellectual sparks leap silently from page to mind. Each spark carries a question. What symmetry binds atoms? How does pattern yield function? Where, inside the seeming chaos of war, does structure wait to be revealed? She sharpens her pencil. The graphite tip gleams ready, and the page welcomes another 1,000 words of inquiry before sleep once again claims its reluctant apprentice. Cambridge horizons. The soot-smudged rhythms of London recede as Rosalind's train slows along the Fenland Flats, where wind-blown reeds bow to the silhouette of King's Chapel rising like a stone ribcage against pale September light. She steps onto the platform at Cambridge with 3 suitcases, one of clothes that smell faintly of mothballs, one of books and notebooks banded in twine, and one of expectation she refuses to name aloud. Around her swirl clusters of freshmen in tweed and optimism, unaware that their new classmate has already survived nights louder than any freshman debate. Porters haul trunks toward cobbled courts. Rosalind shoulders her own satchel and follows street signs toward Newnham College, one of the few academic sanctuaries available to women. The iron gates bear climbing roses that have kept blooming in defiance of rationed fertilizer, and their persistence feels like an omen. At the porter's lodge, she signs her name in a flour-smudged ledger, receives a brass key, and climbs a narrow staircase to a room that overlooks a lawn clipped with almost mathematical precision. There is a desk beneath the window and a wooden bookshelf whose emptiness thrills her. It is unwritten potential, an invitation to be filled with crystallography journals. Lectures begin at once, brisk and unceremonious. She sits in a cavernous theater where male undergraduates occupy the central rows and women file dutifully to the periphery like punctuation marks. Professor Neville Mott introduces wave mechanics with chalk strokes so quick that dust drifts behind him like comet tails. Rosalind copies the differential equations in a precise italic hand, but her mind rearranges them into diffraction scenarios. What if this wave encountered an ordered lattice? How would phase interference map into intensity? When laughter ripples because Mott mispronounces De Broglie, Rosalind stays silent. She is busy calculating. Practical sessions unfold in a laboratory that still bears the scars of hasty wartime evacuations. Stored gas masks atop reagent cupboards, blackout paint peeling from panes. Her supervisor, a kindly but harassed lecturer named William Price, shows her the department's aging X-ray apparatus, an arrangement of lead bricks, filaments, and fragile photographic plates that must be handled like reliquaries. Many students treat the machine as an exam obstacle, but Rosalind studies it as though it were a novel written in copper wire and collimators. She sketches its every flange, labeling angles where Bragg reflections will be sharpest. Price, impressed by her meticulousness, grants her extra evening hours to experiment once formal labs close. Those evenings become a private kingdom. Long after other students depart for sherry and debate clubs, she locks the heavy laboratory door, threads silk scarves over the lamps to soften their glare, and begins aligning powdered crystals of ammonium sulfate inside thin glass capillaries. The room is so still she can hear the hum of the power transformer modulate when she adjusts current. She times her exposures with an alarm clock that once belonged to her grandmother. The tick-tock punctuates her concentration like a metronome. When the beam strikes the sample, cone-shaped halos bloom on the plate, and she feels a hush inside her chest, each halo a syllable in matter's hidden language. Tea breaks are taken not in the senior common room, where jokes about girls playing scientist still circle like pipe smoke, but in Newnham's small kitchenette, where she and a tight knot of women exchange strategies. Borrow lab coats cut for men and roll the sleeves, request instrument time in writing so denial leaves a paper trail, read each new physical review article before breakfast so no tutorial question can catch them unaware. They speak quickly, as though time itself could be confiscated. When laughter rises, it is not giggle but percussion, forged from shared resistance. Outside the microcosm of the lab, Cambridge life is an oxymoron of cloistered war. Air raid drills continue. Chapel bells toll for vespers and casualties alike. One frosted dawn she cycles along the backs and sees Trinity's stone balustrade laced with sandbags that resemble giant sleeping serpents. She imagines X-rays passing through those sandbags, scattering off quartz grains, painting faint rings that even bombs cannot erase. The thought comforts her. Order is resilient, patterns recur. Midterm tutorials test that resilience. Dr. Jeffrey Warren, graying and vaguely amused, quizzes her on Lau equations. She answers swiftly, but he interrupts. Miss Franklin, why chase such esoterica? Industrial chemistry needs bright minds far more than these airy wave theories. She inhales, counts to 3, Bragg angle discipline, and replies that understanding structure underpins every industrial solvent he might tomorrow pour into a vat. Without theory, factories are blind. He raises an eyebrow, chalk squeaks, but he does not contest her again that hour. Later in the corridor, a male student mutters, "Stroppy," as she passes. She notes the slur, files it as irrelevant data, and keeps walking. Weekends find her in the Cavendish Library, a dim sanctum scented with old leather and lamp-heated dust. She pores over pre-war papers by Sir Lawrence Bragg and Max von Laue, tracing derivations in the margins. She copies entire pages into her notebook, then rederives them to confirm no coffee-fueled oversight. Sometimes she forgets to eat. A sympathetic librarian slides her ginger biscuits wrapped in blotting paper. She devours both biscuit and paper notes, ingesting knowledge as glucose and ink. Christmas break offers no real respite. She remains in Cambridge, volunteering for a civil defense watch at night and returning to the lab by dawn. One quiet Boxing Day morning she mounts a crystal of cholesterol on the goniometer. Its greasy translucence mocks her clamps, slipping repeatedly until she rigs a thread of beeswax to hold it steady. 12-hour exposure, she writes in her log, then settles at the desk to translate a French article on Fourier transforms. The exposure ends after dark. She carries the chilled plate to the darkroom, rocking developer gently until ghostly arcs appear. Unexpected, asymmetric, beautiful. They hint at a monoclinic lattice she has not yet encountered. She records every arc distance, even those partly obscured by a fingerprint left by her own hurried thumb. Errors, she believes, tell their own stories. By spring, Price arranges for her to present preliminary findings to the departmental seminar. She prepares obsessively, redrawing each diagram in India ink, rehearsing timing so the conclusion lands exactly on the gong that signals tea. The seminar room is packed. Curiosity about the Newnham crystallographer has grown amid whispers that she calculates faster than the departmental slide rule. She begins, voice steady, accent clipped, by explaining intensity ratios, then unveils a 3D model of a soot particles carbon framework built from knitting needles and cork balls scavenged from the college laundry. Questions follow, some incisive, some laced with patronizing surprise. When an elderly fellow remarks that her results are remarkably tidy for a woman's data, she smiles thinly and replies that cleanliness is an advantage of precision, not of gender. A few laughter ripples. Some are with her, some unsure. Hardly matters. What matters is that the diffraction peaks align with her calculated lattice parameters to the third decimal. Precision wins arguments silently. That night she cycles back across the river, moonlight flashing on her bicycle spokes like X-ray scatter, and feels a current of resolve coursing colder than the cam. She has glimpsed how quickly data can command respect, provided the data are irrefutable and the presenter unflinching. She promises herself never to concede a decimal, never to apologize for intellect. Ahead, Newnham's iron gates gleam, and the roses planted last autumn have already unfurled new buds, indifferent to blackout or barrage balloons. She coasts to a stop, breath frosted, heart drumming an internal meter. In the silence between pedals, she realizes that Cambridge has not merely educated her. It has sharpened her into an instrument prepared to carve patterns from secrets yet denser than graphite. Inside her room she lights a small lamp, spreading the seminar notes across the desk. She annotates them with improvements for next time, then flips to a blank page and titles it, Future Work. Below, she writes 4 words that seem to hum against the paper's grain. Fine fibers. Biological origin. She underlines the phrase twice, closes the notebook, and lets exhaustion finally claim its hours. But even as her eyes close, she sees faint diffraction rings drifting across the ceiling. Haloed promises that someday she will aim an X-ray beam not at soot or cholesterol, but at the very blueprint of living cells. Somewhere, those halos are already waiting for her lens. Paris Interlude. The overnight couchette from Victoria to Gare du Nord rattles past iron bridges and beet fields gone silver under a waning moon. When the train exhales at last beside the soot-streaked platforms of post-war Paris, Rosalind steps onto foreign stone with a battered valise in one hand and a letter of invitation from Jacques Mering in the other. The war has been over scarcely 2 years, yet city walls still carry bullet pocks, and piles of salvaged bricks cluster like sleeping dogs along the boulevards. Even so, the air thrums with an irrepressible confidence she has not felt in London since before the sirens began. Her French, acquired from textbooks and the quick tutelage of Newnham's language coach, unfurls awkwardly at first. She negotiates a chambre de bonne under the mansard roof of a sandstone building on Rue de l'Observatoire, climbs 6 flights each night past the nostalgic smell of boiled chicory and furniture wax, and falls asleep to the hum of distant accordions drifting across Montparnasse. In the morning, she walks to the Laboratoire Central de Services Chimiques de l'État, a low, limestone structure whose courtyard plane trees have somehow survived blackouts and shortages. Above the entrance hangs a modest brass plaque. To her it gleams brighter than any county crest. Inside, benches are crowded with improvised apparatus, vacuum pumps repaired with bicycle valves, lead glass shields salvaged from hospital basements, and a hulking X-ray generator whose transformer coils give off an ozone tang. Everything looks patched, resurrected, alive. Mering greets her in a cloud of cigarette smoke, sleeves rolled, hair an unruly halo of gray. He waves away formalities and dives straight into diffraction diagrams, praising not only their elegance but their utility to industry rebuilding its furnaces and turbines. For Rosalind, accustomed to British Reserve, the directness feels like stage lights clicked on mid-speech. She finds herself answering with equal spirit, explaining her Cambridge work on coal porosity, sketching Bragg cones across a blackboard already ghosted with yesterday's chalk. Life settles into a syncope of long laboratory sessions and equally long café debriefs. The French students include Colette Weil, who races Rosalind up the spiral stairs to the rooftop every day at noon, and Henri Adrien, who punctuates Fourier equations with jokes so clever they survive translation. They treat her not as a novelty but as an indispensable collaborator. When she proposes using a Patterson synthesis to model disordered carbons, they simply hand her graph paper and argue about phase angles until the bartender calls furniture. In the evenings she peddles a borrowed Villa Solex along the Seine. Stone quays glimmer with reflected neon, bookstalls reopening, barges loading wine casks, lovers practicing resistance to curfews now lifted. She lingers on Pont des Arts, watching the water coils twirl under the arch. The vortex reminds her of scattering vectors rotating in reciprocal space, and she laughs quietly at her own tendency to convert scenery into mathematics. Weekends open onto galleries. At the Musée d'Art Moderne she studies Mondrian grids, noting how their disciplined orthogonality echoes lattice planes. At a small left-bank cinema she discovers Renoir's long tracking shots and scribbles in her notebook. Continuous motion can reveal hidden structure, just as continuous rotation of crystal reveals identical diffraction. Observation, she realizes, can migrate between arts without losing potency. Back in the lab the work deepens. Her project, to determine how coal becomes industrial graphite under heat, a transformation crucial for aircraft pistons and reactor moderators. She packs powdered carbon into thin-walled glass capillaries, aligns them within a specially modified camera that shields stray electrons, and exposes them for hours while the building's plumbing knocks like a bass drum. After development, she measures ring diameters with vernier calipers, painstaking to the tenth of a millimeter, then feeds the numbers into a hand-cranked calculating machine, its gears clacking like an itinerant jazz band. Gradually, patterns emerge. Poorly ordered carbons display smeared halos. Annealed carbons sharpen into discrete arcs. Full graphitization resolves into needle-thin spots. The sequence tells a story of atoms sliding, stacking, fusing, an alchemy of heat and time. With Mehring, she drafts a paper arguing that ordered graphite arises not in a single leap, but through intermediate turbostratic layers. The manuscript circles through peer review swiftly. France, hungry to reclaim its scientific stature, publishes it in Comte's Rondeaus within weeks. For Rosalind, it is the first time her name appears as lead author, and the confidence that follows is not so much pride as a steadier heartbeat. Spring of 1948 brings late frosts and new challenges. The lab receives funding for a more powerful X-ray tube, but customs delays extend for months. Instead of waiting, Rosalind devises a workaround, stacking multiple weak exposures and mathematically summing their intensities. Late nights, she sits at a drafting table overlaying translucent films, aligning faint smudges until a coherent lattice snaps into view. The trick will later echo in digital image stacking, though she cannot yet imagine silicon chips. For now, she trusts only slide rule, compass, and her unforgiving eye. Beyond science, Paris continues its seduction. She joins colleagues for Sunday rambles in Fontainebleau Forest, where sandstone boulders jut like whale backs among heather. They picnic on rye bread and sardines, then practice orienteering with outdated maps, relishing the minor peril of getting lost together. In her letters home, Rosalind describes these outings sparsely. Good exercise, better geology. But between the lines, her parents sense a daughter blooming under skies unscarred by barrage balloons. That summer, Jacques Mehring invites her to lecture at the Société Française de Minéralogie. Inside a wood-paneled hall on Rue Saint-Jacques, she presents her graphite sequence to an audience of professors in threadbare morning coats and young engineers still shaking wartime dust from their hair. Questions fly, about instrumental error, about the role of catalyst metals, about whether her method could illuminate biological fibers. The last query, posed by a visiting physicist from London named Maurice Wilkins, lingers. Biological fibers. Keratin, collagen, perhaps even nucleic acids. Rosalind answers cautiously that the principles apply, though sample preparation would be delicate. Wilkins nods, makes a note, and after the lecture invites her for coffee the next morning. They meet at Café Flore. He speaks of a newly funded biophysics group at King's College London, of rumors that genes may reside in a giant molecule whose structure remains a cipher. He asks, almost offhand, whether she would consider applying her diffraction expertise to this puzzle. Rosalind listens, intrigued but non-committal. She has just begun to belong here. Still, the phrase giant molecule echoes like a cathedral bell. Weeks pass, and the idea refuses to stay politely silent. Late one October night, while annotating intensities of 002 graphite reflections, she finds her pencil has drifted to sketch a twisted ladder, rails of sugar phosphate, rungs of paired bases whose names she vaguely recalls from a biochemistry primer. She shakes her head, amused, tears the sheet away, but the image persists behind her eyelids. By winter of 1950, the laboratory has blossomed. The new tube finally arrives. Iron shutters clatter open, spilling brighter beams onto finer crystals. Yet another letter arrives too, this time from Sir John Randall, official and persuasive. He offers a 3-year research fellowship, a microfocus X-ray camera to be built to her specifications, and the chance to be first to photograph the inner code of life. Paris has given her camaraderie, competence, and a taste for midnight conversation, but London now offers a horizon drawn in nucleotides. On her final evening, colleagues crowd the lab's narrow corridor, balancing champagne flutes scavenged from somewhere in the Latin Quarter. Mering toasts La plus exact de nous two, and Colette slips a tiny notebook into Rosalind's pocket, its pages blank for discoveries to come. They walk her to the metro, their laughter echoing down the tiled passageway until the train doors close. When the carriage surfaces onto the iron viaduct above the Seine, winter lamps shimmer in the current. She presses her forehead to the glass and watches the river twist like a dark ribbon, an unwound helix, between embankments lit with promise. Tomorrow she will face again the smug courtyards of King's College. Tonight she lets the city impart one last lesson, that freedom and fellowship can accelerate thought as surely as any magnetic coil. The train dives into the black mouth of a tunnel, and Paris disappears, leaving only the steady pulse of possibility in her chest. King's College contrasts. London's embankment greets her return with coal-smudged air and the slow clang of river barges nudging the piers. King's College rises above the Thames like a brooding fortress, Gothic towers of soot-black stone stitched with newly installed telephone cables, brass plaques burnished by generations of hopeful fingerprints. Inside the Strand's main archway, Rosalind finds a slip of paper thumbtacked beside the porter's ledger. Biophysics Unit, Basement 3. The arrow points downward, as though mapping her first descent into a labyrinth equal parts promise and unease. Sir John Randall meets her at the stairwell, a trim man in a chalk-striped suit who speaks in staccato bursts about grants and timetables. Funding is tight, electricity rationed, but the unit now owns a microfocus X-ray generator capable of 15-minute exposures. A racing bicycle compared to Cambridge's tricycle, he boasts. He ushers her into a corridor that smells of damp plaster and overheated copper coils, past doors labeled proteins, viruses, fibers. The space Randall reserves for her is barely larger than a domestic scullery. Concrete floor, green-painted pipes condensing droplets, a single-barred window leaking street noise. Yet on the central bench sits the promise, a brand-new London Scientific Instruments X-ray camera, its lacquered casing still gleaming under packing grease. Maurice Wilkins appears in the doorway, thin-lipped smile already fraying. He offers a hand, then withdraws it to adjust his spectacles. Their exchange is polite, but confusion flickers. Wilkins had assumed she would assist his own DNA project. She has arrived believing DNA fibers are now her domain. Randall, impatient for discovery, leaves the ambiguity unresolved. The corridor light ticks off, on again, as though blown by a draft no one admits to feeling. She does not dwell on it. Instead, she rolls up her sleeves and inventories equipment, spools of fine copper wire, capillaries, photographic plates, desiccators, a humidity chamber she immediately declares insufficient. Without controlled hydration, DNA behaves like a capricious violin string, tightening or slackening with every shift in damp London air. She requisitions cedar boxes, salts, airtight bell jars, and within a week converts a broom closet into a climate vault whose temperature she can hold to 0.5 degree. More like a cheese cave than a lab, Gosling jokes when he arrives. Raymond Gosling is her assigned graduate student, ginger-haired, brisk, and eager. Their first joint task: retention King's aging DNA fibers. They fetch vials of sodium thymonucleate shipped from Rudolf Seiner in Switzerland, viscous as honey and twice as temperamental. Rosalind threads the solution onto tiny glass supports, letting gravity coax it into gossamer strands, eyes level with the fiber so she can judge symmetry by reflection alone. Once, a droplet quivers about to snap. She steadies it with a breath measured as carefully as any equation. Gosling watches, notebook forgotten, realizing supervision can be choreography. Weeks slip into a rhythm dictated by exposure schedules and the hum of vacuum pumps. Mornings, she calibrates the beam, aligning nickel-filtered copper K-alpha radiation through 0.7 mm collimators. Afternoons, she and Gosling plot emerging reflections on polar graph paper, dots marching outward like constellations across a night sky. Two distinct diffraction patterns emerge. At low humidity, the fiber yields long, sharp meridional reflections. The A form, tight and impoverished of water. Increase the humidity to 92% and the pattern blooms into a striking cross, arms splayed at 60 degrees, layer lines spaced 3.4 angstroms apart. This is the B form. They decide, soft and well hydrated, a molecule swelling with possibility. Every discovery arrives shadowed by tension. Tea room gossip mutters about Franklin's fortress, implying that her insistence on closed doors and precise protocols is arrogance rather than necessity. Wilkins, feeling sidelined, drops into the lab unannounced, peering at notebooks, asking when he might borrow the camera back. She replies evenly that when his own samples match her fiber quality, time will be divided. Until then, duplication wastes potential. Gosling later sketches the scene in his diary. Two intellects circling like chess queens on opposing colors of the board. January 1952 freezes the Thames. The cold seeps into basement 3 until breath fogs above the exposure table. Rosalind works gloveless, claiming she needs to feel the camera controls. Chalky cracks open across her knuckles, reminiscent of the fissures she once mapped in charcoal lattices. A courier delivers a crate of Ilford nuclear research plates, finer grained than anything Cambridge possessed. Excitement flickers beneath her usual composure. That evening she and Gosling mount a pristine B-form fiber, align the beam, and set the shutter for 2 hours. They pace the corridor to keep warm, debating whether the rising third-order layer line they recently measured implies 2 nucleotide strands or 3. When the alarm clock finally rings, they retreat into the red-lit darkroom. Developer swirls, silver halides awaken, and an image inches into being. A bold X flanked by 10 sharp layer lines, each a rung in some invisible ladder. At the center blooms a black oval whose diameter matches precisely 3.4 angstroms multiplied by 10, the helical pitch. Rosalind holds the dripping plate by its corner, water pooling at her elbow, eyes narrowed not in doubt but in confirmation. Gosling, gooseflesh prickling, breathes. "It's perfect." She nods once. Photograph 51. She labels it in pencil on the glass edge, a neutral tag among dozens, unaware that this negative will become famous enough to earn its own mythology. Perfection demands repetition. All that week she recalibrates, tweaks humidity, retentions fibers, proving the pattern reproducible. Each success tightens the coil of rivalry beyond her lab door. At Thursday's unit seminar she presents preliminary measurements: 9 angstrom radius, 34 angstrom repeat, evidence for antiparallel strands. Wilkins asks if she has considered a helical backbone. She counters that the intense equatorial reflection indicates a high water content and feels a helix may not satisfy the density. The debate edges toward Kurt. A murmur ripples through the audience of physicists and medical doctors unused to such forensic dueling. Outside seminars, her life compresses to narrow corridors and late-night Holborn walks back to digs on Mecklenburg Square. Gaslights halo pavement puddles. She counts footsteps, translating them into nanometers, amused by the brain's refusal to abandon scale. Letters to Mering in Paris confess frustration. J'ai lutte contre de phantoms administratifs, yet also exultation at the clarity of the new patterns. He replies with sardonic cheer. Le progrès est toujours un peu solitaire. Progress is always a little lonely. Spring arrives. London plane trees dust the river with pollen that settles on lab sills, a golden film she wipes each morning before sealing the darkroom. She drafts a full manuscript. Structure of deoxyribose nucleic acid. 60 pages, 9 plates. Tensor mathematics tucked into an appendix slender as a scalpel. She sends LaTeX-style proofs to Acta Crystallographica and commands Gosling to begin third-party verifications. Meanwhile, rumors seep in from Cambridge. Watson and Crick, newly allied, have resumed model building despite previous censure. She is irritated, not fearful. Models built without hard constraints are castles of playing cards. June heatwave. The basement grows subtropical. She compromises by working at night. Laboratory windows cracked to the thrum of passing trams. One such night Wilkins unlocks the door while she calibrates. He asks to borrow several negatives to show a visiting American. Alex Stokes, she assumes. She hesitates, then chooses a less precise A-form plate. Photograph 51 she locks in her drawer. Trust, she decides, must be as carefully titrated as humidity. Still pressure mounts. Randall wants results suitable for funding renewals. Wilkins wants ownership clarified. Gosling wants a thesis and perhaps unspoken peace among mentors. Rosalind shoulders it all with disciplined calm. Yet by autumn the strain settles in the set of her jaw. She begins eating lunch alone on the college roof. Coat flapping in city wind. Sketching diffraction intensity curves against a backdrop of cranes rebuilding South Bank theaters. One crisp October afternoon, clouds piled like cotton behind St. Paul's Dome. She watches pigeons gyre and suddenly perceives the entire helix question differently. If base pairs lie perpendicular to the fiber axis, then hydrogen bonds could unify strands while preserving symmetry. She sketches furiously, arrows, angles, distances. Back in the lab she measures the intensities again, and realizes the pitch matches a two-strand helix after all. Excitement sparks. A clean, white-hot line through weeks of gray contention. Yet she will not publish until every variable bows to verification. That reverence for accuracy, more than rivalry, defines her progress at King's. By the close of 1952, she possesses data precise enough to anchor any model, yet still refuses premature speculation. She files photograph 51 with others in a steel cabinet, logs conditions in ink so neat it could pass for typography, and prepares for the new year with a resolve burnished by charcoal nights and sodium DNA fibers stretched to their gleaming tension. Unaware of how soon that image will travel corridors beyond her control, she locks the cabinet, extinguishes the basement lights, and climbs the stairwell toward the winter dusk, her mind already parsing tomorrow's equations in rhythm steadier than the college bells tolling vespers far above. A helix unveiled. January 1953 begins with freezing rain rattling the glass panes of basement 3, the laboratory lights flickering as though reluctant to illuminate a new year. Rosalind arrives before dawn, umbrella dripping down the stairwell, steam spiraling from her collar. She removes her coat, ties a cotton scarf over her hair to keep errant strands from contaminating sodium DNA fibers, and checks the climate vault gauges. Relative humidity 92%, temperature 20.4 degrees Celsius, perfect. Raymond Gosling follows minutes later with 2 cups of watery tea balanced on a clipboard covered in intensity tables. They plan the morning methodically. Retention sample G24, run a 4-hour exposure, log density data for the upcoming Cambridge lecture. Outside, traffic groans across Waterloo Bridge. Inside, only the click of the shutter and the soft ticking of Rosalind's grandmother's alarm clock mark passing time. Late that afternoon, while she measures fresh layer-line spacings, Maurice Wilkins appears in the doorway with a half-apologetic smile. "American visitor in town," he explains. "Jim Watson back at the Cavendish. Thought I'd show him something of our progress." Rosalind, nose still over a loop, murmurs a courteous acknowledgement, assuming he means a quick tour of the basement or perhaps a glance at yesterday's spotty A-form plate. She does not realize Wilkins has already slipped into her filing cabinet, its locked trivial beneath his practiced twist, and selected photograph 51, the sharpest B-form negative she ever made. Nor does she see him cross the courtyard carrying the still damp print inside a manila folder, beating a path toward King's Grand Gate and the Cambridge train. 2 days later a letter lands on her desk, stamped Cavendish Laboratory. It bears polite thanks from Watson for the illuminating discussion Wilkins recently afforded, and asks if he might trouble her for numeric data on hydration curves. Rosalind frowns, there was no recent discussion, and sets the letter aside. She is committed this week to finishing her manuscript for Acta Crystallographica, and external distractions feel like sand in delicate bearings. She returns to calculating fiber diameters in angstroms, gray eyes narrowing with each refinement of significant digits. Meanwhile, in Cambridge, Watson unfolds photograph 51 beneath the glare of fluorescent lamps as Francis Crick leans in, eyebrows arched. The black oval of the central reflection, the 10 crisp layer lines, the unmistakable 60-degree arms, all translate instantly into helical parameters: 20 angstrom radius, 3.4 angstrom rise per base pair, 34 angstrom pitch. For Watson and Crick, who have been kept from model building since their magnesium ribbon fiasco, the image is a pistol crack at the starting line. They pin it to the corkboard, surround it with cardboard nucleotides cut from cereal boxes, and begin rotating sugar phosphate backbones in eager bursts of hypothesis. Back in London, Rosalind spends evenings in her digs on Mecklenburgh Square, drafting her lecture slides by the orange glow of a paraffin heater. The talk, scheduled for mid-February at the Cavendish, will showcase her latest precise measurements: water uptake curves, fiber spacing tables, and a caution that any model must reconcile density with hydrogen bond geometry. She chooses every word carefully, wires each argument like circuitry, determined that data, not conjecture, will dictate structure. Her colleagues at King's focus on separate projects. The tensioned calm of the basement seems briefly hers again. Friday, January 30th, she travels to Cambridge, suitcase bumping across the platform. She enters the Cavendish Lecture Theatre, a spacious hall faintly smelling of pipe tobacco and tin polish. Watson and Crick sit near the front, notebooks ready, eyes gleaming. Rosalind begins her talk, voice clear, cadence deliberate, presenting the axial rise, the strong equatorial reflection, the evidence for 2 water layers surrounding the fiber. Students scribble, postdocs whisper, and Watson's grin tightens each time her numbers confirm his cardboard mock-ups. She notices the grin, interprets it as impertinence, but keeps her focus on the projection screen where photograph 51, now properly hers, dominates the shadows. Afterwards, Crick corners her by the tea urn, praising her beautifully definitive distances, while probing for her view on helical symmetry. She remains non-committal, noting that her Patterson maps could equally suit a non-helical backbone if base pairing alternates. Crick's smile holds admiration and urgency in equal measure. He departs with a flourish, vowing that science will settle it soon. Rosalind packs her slides, resigned to a long night train, unaware that in nearby rooms Watson and Crick will remain awake past dawn, atoms dancing in their heads like children about a maypole. February turns brutal, snow crusting London streets, but the basement humidity chamber hums like a tropical terrarium. Rosalind and Gosling refine a new series of B-form exposures at slightly alkaline pH, observing minute shifts in pitch length. She drafts a second manuscript, this one for Nature, stressing that any double helix must place phosphates externally, not internally, else the charge density would be intolerable. She calculates helical twist angles, finds 2 plausible families, 28 degrees and 36 degree, and drafts a paragraph warning against premature model building unchecked by quantitative tests. Unknown to her, Watson has carried her lecture numbers back to Cambridge, where Crick plugs them into his own helical diffraction formulas derived from Cochrane, Crick, and Vand. The math sings. Rosalind's axial repeat and equatorial spacing perfectly fit a right-handed, antiparallel double helix with specific base pair tilt. Within days, the cardboard model solidifies into metal plates and brass rods. They send short notes to Nature reserving space for communication on the structure of deoxyribonucleic acid, and telephone Maurice Wilkins to request confirmation. Wilkins agrees, partly relieved to sidestep further conflict, partly dazzled by the elegance of the model. He plans a visit, carrying yet more of Rosalind's data in his briefcase. March 1st, a dull Sunday, finds Rosalind alone in basement 3 measuring a fresh batch of diffraction plates when Randall steps in with tight-lipped embarrassment. Funding renewals require staff reorganization, he says. She is to transfer to J.D. Bernal's crystallography group at Birkbeck College by summer. The move, framed as promotion to senior researcher, feels like eviction. Her calm cracks for a heartbeat. Why shift projects just as DNA approaches resolution? Randall mentions better opportunities, studying viruses with electron microscopes. She realizes politics has trumped precision. She nods once, thanks him, and returns to her densitometer, pulse hammering in her ears louder than the clatter of student footsteps overhead. Mid-March, rumors leak. The Cavendish duo claims to have solved DNA. Gosling bursts into the basement waving a telegram from a friend up north. Helix found. Watson crick to publish. Rosalind sets down a fiber with deliberate care, removes her goggles, and asks him to double-check the humidity bath. Externally she shows only a thin smile. Internally she tallies every constraint they might have violated. She is certain density arguments forbid phosphates inside. She is certain correct models demand her water content data. Yet she has not shared all her notes publicly. How, then, have they satisfied the mathematics? On March 28 she receives the galley proofs of their forthcoming nature letter, slipped under her door by an apologetic Wilkins. She spreads the pages across her kitchen table, lamp flickering. There it is, a right-handed double helix, bases paired inward, phosphate backbone outward. Exactly the arrangement her most recent draft proposed but had not yet submitted. The text thanks Wilkins for showing us his unpublished results and especially the X-ray diffraction pattern that guided model building. Her heart lurches. She sits for a long time, fingers splayed on the table, noticing a small scorch mark where the paraffin heater once sparked. She thinks of all the nights she measured layer line spacings to 1/10 of a millimeter, wiped dust off humidity gauges, risked radiation exposure for precision. She touches the printed words again, feeling the relief of truth revealed and the sting of attribution misplaced. April arrives with rain glossy on the pavements, blossoms erupting in squares once cratered by bombs. Rosalind formally accepts Bernal's invitation to Birkbeck, packing notebooks, photographic plates, and her grandmother's alarm clock into wooden crates bound in twine. On her final morning at King's she unlocks the steel cabinet, removes photograph 51, looks long at the perfect cross, then slips it into an envelope addressed to herself at Birkbeck. She leaves a carbon copy of her manuscript on Randall's desk, annotated in red ink, submitted for publication. Then she climbs the stone steps into grey daylight, the Strand humming with buses and impatient car horns, and turns east toward new work, new lattices, new mysteries, carrying within her the unspoken conviction that accuracy, though sometimes outpaced by spectacle, endures like the backbone of the helix itself, silent and unbreakable. Virus symmetries. Birkbeck College sits at the eastern edge of Bloomsbury like an unsung cantata. Plain brick, perfunctory windows, iron railings that clatter whenever taxis rush past on Torrington Square. Yet inside its haphazard corridors Rosalind senses a quickening, something akin to opening a well-worn notebook and discovering a blank, forgiving page. J.D. Bernal greets her in an office that resembles both library and bicycle shed. Books piled to the ceiling, spare gears from his beloved touring cycle stacked under a drafting board, coffee rings blooming across reprint bundles. His handshake is warm, his first sentence perfectly direct. Forget who found what helix, we have new puzzles. Viruses are crystals that can multiply, and the world needs someone who sees patterns the way you do. He partners her with Aaron Klug, a soft-spoken New Zealander whose eyebrows lift in permanent, curious arcs, and with John Finch, a graduate student eager as a greyhound at the gun. Their common inheritance is a basement laboratory scarcely larger than the King's chamber she has just vacated, but its walls are lined with pale, humming cabinets, electron microscopes capable of magnifying matter until atoms parade like regimented marbles. Rosalind listens as Bernal outlines the target, Tobacco mosaic virus, a slender rod that cripples crops yet dazzles physicists with regularity so precise it might have been machined. 1,400 identical protein subunits spiral round a coil of RNA in near-perfect helix. X-ray it, and you capture life's architecture at its most economical. She starts by requesting better fibers. No fragile DNA threads this time, but robust viral rods extracted from infected leaves. Klug arranges shipments from Cambridge horticultural glasshouses. Wooden crates arrive, each leaf sealed in waxed paper, veins blackened by disease. In the fume hood, Rosalind pulverizes leaf tissue with a porcelain pestle, a verdant aroma rising, cut grass and faint tar. She purifies the virus through a gauntlet of filters and centrifuge runs, yellow-green pellets forming at every spin, glinting like peridot in tungsten light. Under the electron microscope, each rod appears as a dappled cylinder, 300 angstroms long, 18 angstroms in radius. She photographs hundreds, then pins the prints on a corkboard, aligning cylinders so their speckled shadows suggest a Pontiest river. Evenings stretch calm here. The librarians allow her to haunt the reading room after hours, translating Helmut Frankl-Conrad's German papers on viral reassembly. She copies passages in fine script, inserting her own marginalia. Self-organization implies symmetrical energy minima. When her neck stiffens, she steps onto the balcony, gulps cold air, and watches Bloomsbury street lamps burn sodium orange halos through the drizzle. Somewhere down Bing Place, a jazz trio practices, saxophone arpeggios threading with passing buses, and she thinks of TMV's protein subunits twirling around RNA with comparable improvisation yet strict meter. By spring 1954, Klug and Finch have adapted King's X-ray camera to accept virus-laden capillaries. Rosalind engineers a hydration chamber whose copper coils purr like a contented cat, maintaining 75% relative humidity, optimal for preserving helical integrity. Exposures tick on through nights fragrant with developer chemistry, and layer lines bloom on plates, broad at first, then narrowing as she fine-tunes beam alignment. Klug calculates Bessel functions to predict where intensity maxima should fall. Rosalind measures, cross-checks, then corrects the theory when data diverges by as little as a millimeter. Their synergy is unhurried, flecked with shared jokes about promoters and bases, coffee spoons and radius values. July's Royal Society soiree provides her first chance to present these virus results. She stands beneath gilded plaster cherubs in the Society's library, pointer in hand, slides showing cross-sections like intricate embroidery. She explains that TMV's RNA nestles in a central channel 40 angstroms wide, its phosphate backbone hugging the inner wall of protein subunits. The helical pitch, 23 angstroms, confirms 2,600 nucleotides per virion. Questions fly. Can the RNA shift position during infection? What of the suspected structural transition at high pH? She answers methodically, voice calm but eyes alight. Among the audience sits Dorothy Hodgkin, who later presses Rosalind's palms in both of hers and murmurs, "You have turned disease into geometry." Back in the lab, momentum builds. They pivot to tomato bushy stunt virus, an icosahedral particle that refuses tidy alignment. Electron micrographs reveal a mosaic of pentamers and hexamers. Rosalind traces each contour with carbon paper, assembling cardboard models of 20 triangles a face until Klug jokes that her desk resembles a child's kaleidoscope. Yet gradually they decode the symmetry. A triangulation number of 360 protein subunits total. She drafts the manuscript, footnotes precise, captions lyrical, an icosahedral shell whose elegance belies its pathogenic duty. Bernal signs off with a flourish. Nature accepts within a fortnight. Autumn 1955 drapes Bloomsbury in chill fog scented by coal fires. Rosalind, now 35, feels both invincible and stretched thin. She gives guest lectures at Oxford, writes grant applications, mentors a trio of students, and still spends dawn calibrating microscopes. One morning she feels a twinge low in her abdomen. shrugs it off as hours-old discomfort from crouching. Weeks later the ache persists, subtle but insistent, like mis-indexed diffraction intensities quietly skewing results. She books a private consultation. The diagnosis, ovarian carcinoma, arrives coded in euphemisms. A growth, early intervention advisable. She blinks once, steadies herself with the same composure she once reserved for air raid sirens, thanks the surgeon, and schedules surgery for February, nudging only 2 lab commitments aside. Recovery is swift at first. Klug brings stacks of diffraction prints to her hospital bedside. She reviews them between morphine-softened naps, pencil circling potential Fourier phase errors. Flowers arrive from Bernal, from Hodgkin, even a polite card from Wilkins. She spends convalescence dictating revisions to students, her voice rasping yet insistent that figure legends remain scrupulously units correct. A month later she limps back into the basement, stitches still tender, and jokes she now has more metal inside her than the X-ray tube. But the lab hushes its celebration. All sense the clock has accelerated. Undeterred, she launches a final project, the polio virus. Funding is scant, yet she persuades the Medical Research Council that understanding its symmetry could hasten vaccine design. She enlists Finch to adapt negative stain EM techniques. She writes late-night protocols dense with variables: stain concentration, exposure temperatures, tilt angles. The disease that once paralyzed limbs now marches under her scrutiny as geometric artillery. Despite recurring fevers, she marches too, carrying notebooks thick with contour maps to her flat each evening, where she works cross-legged on the floor, scarf round her shaved head, tea gone cold at her knee. By spring 1956 she submits a trilogy of papers: TMV structure refined to 2 angstrom resolution, comparative analysis of spherical plant viruses, preliminary symmetry of poliovirus. Reviewers praise the rigor, the unflinching correlation of X-ray and EM data. Colleagues whisper that she is forging an entire discipline: structural virology. One afternoon Klug finds her asleep at the bench, cheek pillowed on graph paper. He drapes his lab coat over her shoulders and silently tallies how many discoveries can bloom in the span of a single determined heart. Summer heat swells London pavements. Rosalind's energy wanes, but her precision never blurs. She strategizes future projects: turnip yellow mosaic, alfalfa mosaic, scribbling them in the petite notebook Colette once gave her in Paris. Margins fill with sketches of protein subunits tessellating into infinite lattices, each vertex annotated: possible, probable, prove. She writes invitations for a symposium on virus symmetry scheduled the following March and seals envelopes without revealing that her own breath now comes in shallow, metronome quick waves. As autumn colors flare across Tavistock Square, she climbs the Birkbeck steps more slowly, pausing to let dizziness subside. Inside, the lab hums on. Finch aligning grids, Klug computing phase angles, Bernal dictating a socialist pamphlet between diffraction solutions. Rosalind presses a hand to the cool doorframe, listening. Pumps thrum, motors whir, glass clinks, an orchestra of inquiry she has helped tune. She smiles, slips on her goggles, and eases back onto the tall stool before the microscope. The fluorescent screen blooms green, revealing a new mosaic of ordered specks. She adjusts focus with fingertips still steady, tracing the dance of viral ghosts assembling into perfect, devastating beauty, proof that pattern endures even as time threads its fragile helix through the days. Illness and reflection. Winter 1956 settles upon London with a severity Rosalind has seldom felt, even during blackout years. The cold seems to seep through the mortar of Bloomsbury's terraced houses and coil around her bones. At Birkbeck, yellowing radiators clang like half-hearted cymbals and do little to warm the basement where she coaxes viral ghosts onto copper grids. Each morning she shrugs off the ache low in her abdomen, the inconvenient echo of February surgery, telling herself that fevers are simply the body's way of adjusting to relentless inquiry. She repeats the mantra of her coal structure days: Accuracy first, discomfort later. Yet discomfort is persistent. In mid-January, a second operation becomes unavoidable. Surgeons remove more tumorous tissue, and afterwards she wakes beneath hospital fluorescents that hum like distant transformers. Her brother Colin stands beside the bed, his physician's composure slipping as he squeezes her hand. She jokes that at least she is finally horizontal long enough to finish Somerville's latest monograph on hydrogen bonding, then grimaces at the hypocrisy of referencing rest she has no intention of taking. When the ward sister arrives with a clipboard, Rosalind politely but firmly requests permission to use the nurse's desk after lights out. The poliovirus manuscript still needs its discussion section, and clarity, she insists, is a potent analgesic. Over the next week, colleagues drift in carrying flowers, oranges, and rolled diffraction prints. Erin Klug brings contour maps traced overnight. She marks corrections in red while intravenous drips hiss beside her pillow. John Finch arrives with logarithmic plots. She asks for an extra pencil so she can recalibrate the vertical scale herself. The rhythm of nurse, visitor, paper, and morphine merges into something almost meditative. Even Bernal, loping through corridors like a benevolent wolfhound, concedes that her determination defies statistical expectation. "You're rewriting the prognosis tables," he says, half proud, half pleading. She arches an eyebrow. "Statistics have always been hostage to outliers," she reminds him. By March she is back in the laboratory, though she walks more slowly, one hand grazing benches for balance as though they were geological strata offering support. She institutes a new rule. No one mentions fatigue until the data are logged. Students obey, masking worry inside extra cups of sweet tea and silent offers to lift lead bricks around the microscopes. At night she writes in the small Parisian notebook about lattice imperfections and about mountains, vivid memories of hiking the Pyrenees before the war. She recalls the way elevation thins the air and clarifies thought, how each summit appears unreachable until just before arrival it reveals a final, forgiving terrace. Illness feels similar. Brutal incline, hidden plateaus. The analogy pleases her sense of structure. Summer arrives with heavy, pollen-laden air that makes breathing harder. Yet the poliovirus project blossoms. Finch proves that the icosahedral shell exhibits T=3 symmetry, and her curated diffraction set resolves to an unprecedented 5A. She drafts a comprehensive paper, hand-inking diagrams with lines so fine they resemble spider silk. Reviewers respond in record time, except with minor revisions. The prospect of seeing poliovirus rendered in crystalline exactitude buoys her even on afternoons when pain slices through conversation and she must pause, palms flat on the bench, until the wave retreats. In September she travels, against medical advice, to an international virus conference in Brussels. The Channel crossing is rough. She braces herself against the rail, salt spray needling her face, telling Finch that seasickness is merely an unsteady Fourier transform. On stage she presents The Geometry of Biological Multiplication, 40 slides in 30 minutes, voice steady despite a stitched-up abdomen and glancing dizziness. The hall erupts in applause unusual for a session thick with equations. Afterwards a young Italian crystallographer asks whether beauty guides her hypotheses. She answers, "Only symmetry. Beauty follows whether invited or not," then signs his conference program in looping blue ink. Back in London the ache returns sharper. Scans reveal metastases, and radiotherapy commences. Brief, searing bursts that leave her nauseated yet oddly tranquil, as though the body accepts a temporary ceasefire. She negotiates treatment times around instrument bookings, an arrangement that bewilders the oncology registrar but earns quiet respect from the radiology technician who, despite hospital protocol, slips her advance copies of Acta Crystallographica while machines cool. She devours each issue, scribbling marginal critiques no one will likely see. Christmas 1957 is spent in her Mecklenburg Square flat, curtains drawn against damp twilight. She decorates a miniature fur with index cards bearing virus symmetry numbers 60, 180, 240, hung by paperclips. Her parents visit, bringing a new wool blanket and memories of childhood menorahs. They urge her to rest. She counters by reading aloud an acceptance letter from microbiology for Clug's latest TMV follow-up, insisting that collective accomplishment is the season's truest warmth. When the family departs, she sits alone beneath the card-laden tree and finally allows exhaustion to hum through her limbs like low-frequency diffraction noise. January sees her back at Birkbeck for what students sense may be a valedictory sprint. She outlines future projects with forensic specificity. Refine turnip mosaic virus to 3A. Develop phase contrast EM for nucleoprotein filaments. Explore potential of neutron scattering at Harwell. She leaves margin notes reading if time remains. But no one is deceived. Clug, eyes bright with unshed grief, promises he will carry each line forward. She replies almost mischievously, "Ensure the density values behave, or I'll haunt your Patterson maps." In March 1958, she collapses after climbing the basement stairs, oxygen elusive as an unsolved structure factor. Admitted to the Royal Marsden, she converts her private room into a satellite office. Papers stacked, diffraction negatives taped to tiled walls, alarm clock ticking beside syringes. Visitors remark that the room feels more observatory than ward. Dorothy Hodgkin sits by the bed one rainy afternoon, holding Rosalind's hand while they debate the merits of direct methods phasing. Hodgkin's tears threaten. Rosalind grips harder, whispering, "No symmetry element ever truly ends, it merely transforms." April 16th dawns pale and drizzling. Around noon her breathing becomes shallow, the interval between inhales lengthening like the widening gap of fading interference fringes. Colin, Finch, and Clug stand vigil, each instinctively counting pulses as though timing an exposure. At 4:15 p.m. the final breath leaves softly, almost politely, and the room slips into a hush so complete that the drip machine seems suddenly loud. Clug notes the time, the way one notes a layer line index, and silently vows accuracy will keep her present. The funeral at Golders Green draws family, scientists, and quiet admirers who know brilliance sometimes travels without fanfare. Bernal speaks of crystalline truth. Hodgkin reads a stanza from Wordsworth about hidden power. Gosling places a single copper grid, scorched from 1,000 electron-volt beam, on the casket. When the service ends, colleagues file out carrying notebooks heavy with tasks bequeathed by a woman who never wasted a decimal. Outside, spring sunlight filters through plane tree leaves, drawing fractal shadows on stone just beginning to warm. In laboratories across Europe and America, news travels. Rosalind Franklin, architect of Photograph 51 and virus symmetries, has died at 37. Letters of condolence mingle with requests for reprints. Conference programs bear black ribbons beside her scheduled keynotes. Yet the data remain polished, precise, indelible. Clug submits their final TMV paper with both names on the title, and when reviewers ask for clarifications he answers in the exacting style she taught him, ensuring no parameter strays beyond tolerance. Late that summer, Finch develops a new poliovirus plate. The diffraction rings sharpen almost imperceptibly beyond previous records. He thinks of the mountain terraces Rosalind once described and realizes this improvement is another narrow ledge she carved before nightfall. In the margin of his logbook he writes, "RF would demand we locate the next plateau." Then he adjusts the collimator, sets the timer, and lets the X-ray beam whisper through the crystal, trusting that accuracy, like the spiral within every cell, will persist long after the hands that insisted upon it are gone. Posthumous legacy. The laboratory lights dim without her, yet their filaments continue to warm glass and graphite, as if reluctant to concede her absence. In the months following April 1958, colleagues at Birkbeck open drawers to find margin notes that feel startlingly alive. Tiny cartouches of angular script reminding them to check anisotropy at high tilt, or reindex weak layer lines. They obey the instructions with reverence, copying her uncompromising diction into new logbooks. Slowly the basement resumes its pulse, but every click of the X-ray shutter now carries a faint echo, like footfall in a hall where the original architect is gone. Across London, Maurice Wilkins wrestles with another echo, guilt that grows louder each time photograph 51 gazes back from his files. He cannot revisit the negative without recalling the moment it left her desk, borrowed under ambiguities he no longer excuses. Even success tastes metallic. When he drafts further reports on DNA hydration, he adds footnotes that cite Franklin and Gosling first, as though retroactive order might mend chronology. The amendment is partial but genuine, a sign that conscience, like diffraction, can sharpen under sustained exposure. 4 years pass. October 1962 dawns brittle and brilliant over Stockholm, the Baltic bright as crumpled foil beneath a low sun. Inside the Karolinska Institute, the Nobel Committee announces that the prize in physiology or medicine will recognize James Watson, Francis Crick, and Maurice Wilkins for their discoveries concerning the molecular structure of nucleic acids and its significance for information transfer in living material. The citation contains no mention of Rosalind Franklin. Posthumous awards are not permitted under Nobel statutes. Reporters assemble analog flashbulbs, capturing the triumphant trio whose grins flicker between celebration and the self-consciousness of men aware that an invisible fourth name hovers above the scroll like a watermark. Back in England, newspapers summarize the honor with blocky headlines. Some editors devote a closing paragraph to the late Dr. Rosalind Franklin, whose X-ray photographs proved valuable, but the wording diminishes rather than elevates. At Birkbeck, students pin clipping after clipping to the corkboard and draw a neat red circle around the phrase, "proved valuable," replacing it with "were indispensable." It is a quiet correction, a footnote to the public narrative, yet each stroke of red ink feels like a metrical beat in a larger poem still being drafted. Meanwhile, the work she championed flowers. Erin Klug, driven by a promise whispered at her bedside, refines electron diffraction methods, integrating Fourier transforms with tilt series photography. In 1968, he publishes the first near-atomic model of TMV, its coordinates singing with the same 23 angstrom pitch she once derived on graph paper. 2 decades later, Klug receives his own Nobel Prize for the development of crystallographic electron microscopy and his structural elucidation of biologically important nucleic acid-protein complexes. During his lecture, he displays her handwriting on the conference projector, those looping R's and decisive dots over I's, then pauses, allowing the audience to absorb a silence more eloquent than any prepared line. Recognition accumulates in other ways. Newnham College installs a brass plaque on the door of the room that once overlooked its clipped lawn, inscribing her name in serifed letters tall enough to catch afternoon sun. King's College, decades after basement quarrels cooled, names a lecture theatre in her honor and mounts a blown-up reproduction of photograph 51 on the foyer wall. Students pose beneath the iconic X, their camera flashes layering new light over the original interference pattern, merging past electrons with present photons in a casual act of reverence. By the late 1980s, a quiet revolution unfurls in classrooms. Biology textbooks begin to feature her portrait opposite Watson and Crick. Early editions choose cautious captions. Her X-ray studies contributed to the double helix model, but subsequent printings grow bolder, framing her as co-discoverer whose empirical rigor anchored the leap of intuition. High school debaters invoke her story when contesting the fairness of scientific credit. Graduate seminars dissect the ethics of data sharing, placing her files, letters, and laboratory logs alongside case studies of Mendel and Lavoisier. In this way, she enters pedagogy not as anecdote but as essential theorem. That evidence earns voice. The 1990s bring genomic sequencing, polymerase chain reactions, and gleaming automated diffractometers that resolve structures overnight. Machines she would have debugged with wry humor. Molecular biologists in Silicon Valley name a data center Franklin Hall, its server racks humming in symmetrical rows like updated virus capsids, storing terabytes of base pair information illuminated by blue LEDs. Visitors pause at a foyer sculpture, a stainless steel double helix spiraling around a backlit acrylic panel etched with photograph 51. Beneath, a single inscription reads, "Precision is never premature." Few recall who first wrote the phrase, yet the sentiment threads silently through grant proposals and nightly code commits. Crystallographers push further. Synchrotron sources concentrate X-ray beams into submicron columns. Cryo-EM flash freezes macromolecules in vitreous ice, capturing conformations once dismissed as noise. Each new milestone traces lineage to her uncompromising demand that signal be separated from artifact. When a European free electron laser delivers femtosecond pulses capable of imaging single virus particles, the press release channels her ghost with startling directness. Life's architecture revealed at last in living motion. One imagines her eyebrow arching in cautious approval, pencil ready to interrogate error bars. Outside laboratories, cultural currents shift. Novelists weave her biography into fictional dialogues about recognition and resilience. Poets liken the blurred halos of early DNA images to the grief halos that sometimes encircle memory. Graphic novelists sketch her silhouette against a web of diffraction rings, captioning panels with lines from Wordsworth she once read to Hodgkin. Even playwrights find her voice, delivering monologues in which she addresses audiences as though analyzing their moral lattice, challenging them to locate symmetries of fairness. The 21st century dawns with new pandemics, new vaccines. When scientists at Oxford design a viral vector platform based partly on the icosahedral principles she mapped, press briefings mention Franklin alongside Jenner and Salk. She becomes shorthand for structural clarity amid crisis. In classrooms, teenage girls trace contact polymer templates of photograph 51 onto t-shirts, wearing the cross as emblem, neither religious nor rebellious, but scholarly, a claim to intellectual lineage. They film TikTok explainers titled, "How Rosalind Franklin's Data Fights COVID-19, their ring lights reflecting as bright circles in adolescent eyes." Approaching the centenary of her 1920 birth, commemorations bloom worldwide. A Mars rover camera captures images of sedimentary layers, and the mission team christens the plateau Franklin Ridge, asserting that she, too, read patterns in layers of time. The International Astronomical Union approves the naming of asteroid 9241 Rosalind Franklin, a tumbling rock whose albedo charts invite speculative comparisons to diffraction intensities. In the popular imagination, she migrates from basement shadows to cosmic vantage, her domain expanding from angstroms to astronomical units, yet always measured in disciplined units. And still, photograph 51 endures, archived in climate-controlled stacks at the Churchill Archives Center, replicated in countless lecture slides, tattooed scorches of silver bromide mirroring the tattoo of her insistence. Scholars debate its provenance, but none dispute its eloquence. Viewers stare into the X and witness an entire epistemology. Knowledge built by patient iteration, by slow exposures and careful subtraction of background haze. The image asserts that discovery is not sudden brilliance alone but the steady accrual of certainty until the truth stands undeniable. Some nights, new postdocs at Birkbeck work late, the basement lit by monitor glow. A draft stirs near the old microscope bay, and a few swear they feel a presence. Just temperature flux, perhaps, or the memory of differential pressure between corridor and chamber. Yet when a measurement converges to the fifth decimal, when residuals shrink below threshold, when structure factors lock into phase and the first electron density map resolves with unmistakable grace, they sometimes whisper a simple thank you into the hush. Accuracy, after all, is cumulative, and gratitude, like diffraction, travels in waves. Thus her story unspools, not as footnote but as fiber twisting through successive generations of inquiry. The notebooks she filled migrate to digital archives. The equipment she tuned becomes museum artifacts. The principles she enforced engrave themselves onto algorithms that refine 500,000 structures a year. Credit, long misaligned, gradually corrects as if coaxed by invisible restoring forces. And somewhere, on a shelf in a quiet reading room, her Parisian notebook lies open to a page where she once wrote in pencil. Symmetry remembers. The graphite still gleams. It remembers, and now so do we. Starlit drift. Night settles over the city, gentle as archival tissue enveloping a fragile glass plate. Close your eyes for a moment and picture the deserted corridors of every laboratory Rosalind once paced. The sodium lamps have clicked off. Only a muted phosphorescence remains where stray X-rays once scattered across polished steel, faintly illuminating benches now cleared of notebooks and reagent bottles. Imagine those benches receding into shadow until they resemble a shoreline at low tide, empty but etched with the shapes of endeavors completed. Upon that quiet shore stands photograph 51, its silver grains long since fixed, yet still releasing a subtle inner glow, as though the negative has learned to sing its own lullaby. The black oval at its center expands, softening into a vignette of warm darkness just large enough to cradle the breath you draw now. In one slow inhale, gather the atmospheres of her story. The blackout lamp, the ammonium sulfate crystals, the Parisian cafés, the humid chamber in King's basement, the tobacco mosaic rods glinting under electron beams. Let them converge like motes of dust spiraling in twilight, each a fleeting spark that once caught the lens of her scrutiny. Feel on the exhale how these sparks drift outward again, settling into a wider constellation that arches over the decades. Each star a question pursued, each flicker a measurement recorded with tireless exactitude. There is no need to catalog them. Precision has already done the counting for you. Your only task is to notice the glow and allow its soft gradient to ease the furrow of your brow. Now picture a staircase rising through that constellated dark, nothing grand. Simple wrought iron rails coiling upward in a double helix. The treads are labeled not with letters or numbers but with delicate layer-line spacings, 3.4a, 10a, 23a, repeating in gentle cadence. With each calm footstep you ascend, yet the staircase also unfurls downward beneath you, implying neither beginning nor end, only motion preserved in balance. Somewhere above, a skylight forms the crossbars of an X. Below, a polished floor mirrors the same pattern in reverse, so that moving forward feels like drifting between twin horizons equally stable, equally forgiving. As you step, notice how your heartbeat entrains to the rhythm that once regulated her shutter clicks. The small metronome of pulse within your wrists slows to match the interval between exposures. Patient, exact, unhurried. Above you float the scent of graphite dust and faint developer, odors that once signaled discovery and now signal tranquility. They mingle with the autumnal sweetness of fallen plane tree leaves, a scent Rosalind often inhaled when she paused outside Birkbeck to gather her thoughts before returning to the hum of vacuum pumps. Let that mingled fragrance ebb and flow like distant tide, drawing restfulness deeper into your lungs. Halfway up the helix, a landing opens into a reading room lit by moth-wing lampshades. Wooden tables display open notebooks. On each page, graphite curves map diffraction intensities so smoothly that your eyes trace them as though they were gentle topographical lines across a dream landscape. No need to analyze the parameters. The curves themselves invite surrender, reminding you that even complexity can be rendered as elegant sweep. A chair waits by the nearest table. Oak sturdy, its back carved with a subtle pattern of repeating triangles. You sit, and in the hush you hear only the faint rustle of thin pages turning themselves, as though the data are still in dialogue with their author across time. A breeze enters, soundless yet perceptible, stirring the experimental notes into a slow dance. The pages flip to a diagram of a virus capsid, triangles tessellated into an icosahedron so perfect you feel the geometry fold gently around your shoulders like a shawl of quiet certainty. Another page reveals the central cross of photograph 51, But now the arms soften into luminous pathways leading from the margins of wakefulness toward a center of profound stillness. Follow one path. It widens beneath your feet like a hillside lane dusted with moonlight. Gravel crunches only in memory. You step lighter until each footfall becomes merely an idea of movement, the body resting even as the story strolls onward. Further along the lane stands an old station platform, deserted except for a single bench and a pocket watch left ticking on its armrest. Its second-hand, bright nickel, marks time not in ordinary seconds but in silvery flashes, each flash equating to one resolved ambiguity, one clarified equation. Sit beside the watch. Feel its rhythm sync with your breathing. In clarity gathers. Out, uncertainty releases. The station clock overhead shows no numerals, only a faint inscription. Accuracy remembers. You close your eyes. The inscription lingers on the backs of your eyelids, glowing steady as a lighthouse. When you open them again, the platform has drifted away, replaced by a shoreline at blue dawn. Gentle waves carry polished pebbles, obsidian, olivine, quartz, each smoothed by relentless motion yet still retaining inner lattice. You reach down, select a pebble the color of distant galaxies, and notice beneath its varnished surface the faintest pattern of concentric rings, cousins to the halos that once appeared on her photographic plates. Curl the pebble in your palm. Feel its cool assurance of hidden order. With a relaxed gesture you offer it back to the tide, watching ripples fan outward across mirrored sky. Ripples broaden into a vast, calm sea, its horizon melting into dawn's first hint of rose. High above, the thin crescent moon fades, replaced by a double helix traced in vapor, two contrails gently wrapping, then dissolving in warming air. Birdsong begins, soft as the hush that follows a completed calculation. Somewhere a city stirs. Newspaper vans rumble, kettles whistle, microscopes resume their hum. Yet you remain on the cusp between night and morning, neither hurried by obligation nor tethered to unfinished steps. The science is continuing elsewhere, carried by many hands. You are free to float a little longer in the interval she made possible, a buffer zone of quiet proof. Allow the shoreline to blur, colors blending until only a wash of muted silver remains behind your closed lids. A final thought wanders in. Every breath you draw arranges molecules into transient constellations. Every exhale releases them to drift, recombine, and perhaps ages hence, form part of another thinker's steady hand. This sharing of atoms, of insight, of unvoiced gratitude, is the great sympathetic vibration that underlies discovery. Feel its resonance ease the last tension in your shoulders, soften your jaw, lengthen the pause after each sigh. And now, with the night's notebook closed and the pencil resting at its spine, surrender to the deep hush beyond words. The lamp inside the laboratory of your mind dims, leaving only the mild afterglow of resolved patterns, too soft to disturb, bright enough to guard your slumber. Drift inward, secure in the knowledge that precision need not wakefulness to endure. It shelters quietly beside you, like a loyal companion, holding the world's structures in gentle equilibrium while you, at last, sleep. Good night.